All right, babies, we are going to talk about example 10. I know that we already went through example 10. We did parts A, B, C, and D. But now in this video, we're going to talk about part E because now we're getting into this idea of what is independence. So if you will look at part E, the question is, are being a smoker and dying of cancer independent of one another? All right, so if I want to know if they're independent, I need to know if the probability of smoking and dying of cancer affect each other. So the way I'm going to formally show this, I am going to start by setting up a conditional. So the probability of being a smoker given you're dying or you have died of cancer, because remember this is the mortality question. All right, so I'm always going to set up a conditional with these two items. By the way, it doesn't matter which way you set it up. I'm going to show you in just a minute. I want to know if this is equal to the probability of being a smoker given you don't die of cancer. So this is how we're going to set up the problem. All right, if you will notice, anytime I've got probability, my probability is always a fraction. That holds true with conditional probabilities as well. So that means that if I'm dealing with the probability of smoker given they died of cancer, that is a fraction, just the same as if I had asked you what's the probability someone who's a smoker died of cancer. All right, but this time that symbol in the middle of smoker and cancer indicates to me that I'm not looking at all 1,000 people. I'm just looking now at these people because it's given that a smoker has cancer. So I am going to set this up just like this. And I'm going to write my fraction smoker, that's 135. Out of 190. So showing an independence problem helps you learn to set up a conditional as well. So I want to know if this is equal to the probability of being a smoker given you didn't die of cancer. Well, the people who didn't die of cancer died from something else. So that's going to be the 465 and the 345. So that goes in my denominator. Because now these people right here are the ones I'm interested in, not all of them. All right, so out of 110, those 110 values, how many people are smokers? Well, if you will notice here, I've got 310 and 205. So that's going to be 515. So I want to know if these are equal to each other. You are not solving an equation here. You are just finding these values. So just to tidy this up a little bit, I'm going to go ahead and find my decimals. Just so I can see this. Okay, well, as you can see, the probability of being a smoker, given you died of cancer, is not equal to the probability of being a smoker if you didn't die of cancer. So the question here is, are these two independent? The answer to the question is no. They are not independent. Why are they not independent? Because they're not equal. Not equal, not independent. Are you with me? I don't know why I put a little dot there, but whatever. Okay, so not equal, not independent. That is exactly what that means. All right, if I had set it up in a different way, let's say I set it up this way, the probability of being a smoker. Same thing over here, 135 over 190. Over here, the probability someone is a smoker. So that's 650 out of 1,000. All right? Guess what you're going to find? You're going to find again that these are not equal to each other because these are not independent of one another. All right, so I think I got that last time. All right, so again, these are not equal, so they're not independent. You get the same result regardless of how you set up the problem. Okay, there's another way you can set up the problem. If I want to know if being a smoker and dying of cancer are independent, I could set it up this way. The probability of dying of cancer, given you're a smoker, is that equal to the probability of dying of cancer, given you're not a smoker? Okay, so over here again, now I'm just looking at the smokers. So let me erase this stuff. So the smokers are these people. So 650 in the denominator, cancer 135. And over here, not a smoker, well, that would be everybody else. Okay, so these 350 people. And the probability of cancer in the top of that is going to be 55. Okay, so again, going to get out my handy dandy calculator here. And let's see what we get. Okay, again, these are not equal to each other, so they're not independent. Do I get the same outcome regardless of how I set up the problem? Absolutely. Could you set this up a fourth way? Yes, you could. You could say the probability of cancer given smoker, is it equal to the probability of just cancer? So there's 4 different ways you can set up each of these problems. You're not going to get the same values each time in this situation, but you are going to get the same outcome. So as long as your setup, dang it, I'm out of control. So as long as your setup matches the numbers, you're good to go, because that's what I'm going to be grading. So that's how you determine if 2 items are independent.